Hello. Last time we have seen the effect of resistance in the conductor. So first we have seen due to resistance there is a voltage drop in the conductor, that is in the line. Second, the effect of resistance is the power loss in the form of heat in the conductor. Now suppose if you take a conductor, it will have some resistance. When current flows through it, let us consider I is the current flowing through the conductor, and this conductor is having resistance R. So whenever current flows through the conductor, there is a power loss which is equal to square of the current into resistance. This loss is in the form of heat. So basically this is not only a loss of power, but at the same time it heats up the conductor. So therefore resistance of the conductor should be minimum. First we have seen the voltage drop in the conductor, and second is a power loss in the conductor, and therefore resistance of transmission conductor or a wire should be minimum. Okay. Now let us see specific resistance or also called as resistivity of the material. Now let us consider a conductor having length 1 unit. So L is the length equal to 1 unit. For example, L equal to 1 meter. Similarly, if we consider the cross section area equal to 1 unit, that is for example 1 meter square. Now let us find the resistance of this material. So R equal to, we know, rho L by A. Therefore rho is the resistivity or specific resistance, L length 1 meter, area of cross section 1 meter square, and therefore resistance of this material is equal to simply equal to resistivity. Therefore resistivity or specific resistance of a material is nothing but resistance of a material having unit length, for example 1 meter, and unit cross section area, for example 1 meter square. Different material will have different values of specific resistance. Therefore, specific resistance or resistivity, and therefore resistance of a material depends upon the type or nature of the material Now let us see unit of specific resistance, which means in which unit the specific resistance of a material is measured. Now R equal to rho L by A, and therefore rho equal to, that is specific resistance, equal to R into A by L. Resistance is measured in ohm, area measured in meter square, and length measured in meter. Therefore, the unit of specific resistance simply equal to ohm meter. Now let us see some values of specific resistance of different materials. We will consider here some materials. For example, silver. Its value is 1.6 into 10 raised to minus 8 ohm meter. Aluminium, its value is around 2.65 to 10 raised to minus 8 ohm meter. Copper, its value is around 1.72 into 10 raised to minus 8 ohm meter. The gold, its value is around 2.44 into 10 raised to minus 8 ohm meter. Iron, its value is 9.7 into 10 raised to minus 8 ohm meter. Carbon, its values are variable. It depends upon the different composition, from 3000 into 7000 ohm meter. Nichrome, its value is 108.5 into 10 raised to minus 8. The mica is around 10 raised to 15. Bakelite, its value is around 10 raised to 10. Rubber, its value is around 10 raised to 16. PVC, 10 raised to 16. So we can see the specific resistance varies according to different materials. Some materials are very low values, some materials we can see the moderate values, and some are very high values. Now the low values material we can use for conducting materials, that is for conductors. So these we can use as a conducting materials. Some materials having moderate values, these we can use for resistance material. To manufacture different resistance we can use these materials. And the materials which are very high values we can use for electrical insulators. So low values we can use for conducting materials, so moderate values we can use for the resistance materials, and high values of specific resistance we can use for insulators. Now let us see the conductivity. The conductivity is nothing but reciprocal of resistivity or specific resistance. Therefore, conductivity of a material is reciprocal of resistivity. For conducting material, its value must be high. That is, specific resistance, or we can say resistivity, must be as minimum as possible. So conductors are made from the material having very high conductivity. The unit of conductivity, so reciprocal of unit of resistivity. Unit of conductivity is reciprocal of unit of resistivity. Unit of resistivity is ohm meter, or also written as Siemens per ohm. So unit of conductivity simply Siemens per meter. Siemens is the unit of conductance, and conductance is the reciprocal of resistance. Now let us see the materials used for electrical conductors. Normally we use copper as electrical conductor, aluminium, brass, bronze, tungsten, silver, lead, tin, etc. These materials have low value of specific resistance or resistivity, and therefore we are using these materials for electrical conductors. For transmission line, we are generally use these two materials. For transmission of electricity, we normally use aluminum and copper.